Okay, so we're trying to use the calculator to find the one proportion z-test to find out, do we have evidence that our proportion of water on the globes is different from the real Earth. So where we're going to go on our calculator is stat and then tests, and then you're finding one prop z-test. So we have one proportion, the proportion of water on the globes, and we're doing a hypothesis test because we want to know if it's different from some claim. So I'm going to push enter. First thing it asks you is for your P0. So this is your null hypothesis proportion, which was 0.71 in this case. Our null would be P equals 0.71. X, again, is a number of successes in your sample. So let's say I got 120 waters, and then N is your total sample size. So maybe I toss the globe 193 times. So X, again, is your number of successes, N is your total sample size. And then you have to choose your alternate proportion. So in this case, I am asking the question, do I have evidence that it's different? So I would choose the not equal to. And then I'm going to go to calculate. So we go to calculate, and it gives us the z-score, the p-value, as well as our p-hat, and then the sample size. So just real quick, z-score would be what we get from our z-score equation. This p equals is the p-value, that's the probability of getting what we got in our sample, or something more extreme. P-hat is just our sample proportion. So it's kind of weird with a proportions problem, p versus p-hat. P is your p-value. That's what we're going to use to make our conclusion. P-hat is your sample proportion. So that would be what we would have gotten if we'd done 193, or what was it, 120 out of 193 would have been that. So p-value is what we would use, and if our alpha was 0.05, we would say, since 0.0069 is less than 0.05, we reject the null. We have evidence that the true proportion of water on the globes is different from on the Earth. The p-value has already been doubled. So if you remember from the first lesson, we talked about on a not equal to hypothesis, we double the p-value, or we double the probability to get the p-value. This has already been doubled. So the calculator literally does all the work for us. If I had done a one proportion z-test with that same data but said I'm testing specifically is the proportion of water on the globes different from or less than, right, you'll notice that my p-value is a little bit smaller because it's actually not doubling it. So the calculator does all the work for you. Once you've got the p-value from the calculator, you make your conclusion. On a test, you do not have to show your formula for z-score as long as you write somewhere in the problem that you did a one proportion z-test. You also do not have to draw and shade a normal model. So z-score, p-value, and then write your conclusion. Those are the things that I want to see. If you don't write one proportion z-test, you have to write out the formula for z-score or vice versa. So that is how you use your calculator for one proportion z-test.